Alright, so now we are going to take one example and we are going to see how this small v variation of the small v, how is it going to give rise to random variates when I'm changing the random deviate, how this random variate values are going to change. So I have here an uniform distribution that you're already aware of. So this uniform distribution is given as 1 by b minus a, where y ranges, it's a distribution of y ranges from a to b. Okay, now the first step is we have to find out the cumulative distribution. Okay, cumulative distribution, the cumulative probability, let's not say the cumulative probability. Okay, so the cumulative probability here at any point y, the cumulative probability would be, let me denote by this, phi of y equals, I integrate it from when, from minus infinity to that particular point a, that particular point y, I have to integrate it. But the thing is, my range here is between a and b, so it won't be from minus infinity, it will be from a to my point y, any particular point y. I have to integrate it, this function dt. So what does it give rise to? It gives rise to the cumulative probability here, fy of y, the cumulative probability till the point y. What is the cumulative probability? I integrate it. Usually the integration, as we already knew before, that it's from minus infinity to that particular point. But here my point does not vary from minus infinity to plus infinity. It varies from a to b. So it's going to start from a up till the point y. I integrate it, I get the cumulative probability. Okay, so so that's what we had mentioned previously to in our the cumulative probability. This is what we had to find out, the cumulative probability we have to check. So here I have this distribution function here, and then I am finding out the cumulative probability at the point y. So what is it? I just integrate it. So y dt is y, so it ranges from a to y, so y minus 1, my y minus a divided by b minus a. So this is my cumulative probability. So the first step is done. I found out the cumulative probability. Now the second step, what I mentioned in the previous video, is that this cumulative probability equals my deviate. Correct? The cumulative probability equals my deviate. So from here what can I say is, so that which means, so cumulative probability of y up till the point y equals my deviate v. Okay, or what can I say? I can say is y equals fy inverse of my deviate. Okay, now from this equation, how to get that fy inverse, how to come up with this relation. Okay, so y minus a by b minus a equals nu, so y equals, minus a will go that side, so it will become, it's not visible, y equals a, okay, minus a comes there, plus b minus a into nu. Correct? What I do is I find out the function of y. I'm although doing an inverse transformation, but I'm actually finding out y when nu is given to me. So how this is going to, just rearranging my equation, I get y equals a plus b minus a times nu. Now what have I done? This value is going to range from 0 to 1. Correct? So I can put it in a computer program, maybe the MATLAB program that we usually deal with. I can put it in a computer program. I can just range my values from 0 to 1. So it can be anything like 0, 0 0.1, 0 0.2, till 0.9, and maybe 1. Okay, however many values you want. It all depends on you. You can also put 0, 0 0.5, 0, 1, 1.5. It depends on how many data points you require. But The only thing is that it needs to range from 0 and 1. So this new value is going to range from 0 to 1, and depending on that you will get y values. So for particular new values, let's say a plus b minus a times 0, you will get one y0 value. Y1 equals, let's say, a plus b minus a into 0.1. Y2 equals a plus b minus a into 0.2. So it all depends on you. You can go on just till y, the last one, a plus the y nth one, okay, into 1, okay. So you are going to vary your variate here. The variate here is going to be varied from 0 to 1, and depending on that, what you are going to have here is various values of y. So now this various values of y that I have here, I can, with that, this I can write my resistance equation, because this resistance equation might depend on this y's, okay. So I write down the resistance equation, which is a function of my y's, and once this is done, I have a huge amount of data. I have a huge amount of data that is going to give me my resistance values, and with that I can make the probability distribution, find out my failure function, and then determine my probability. But basically what is here we have to understand is that we have to generate random variables. We have to generate random variables, and these random variables, although they are random, they need to be confined within a range, otherwise we will get stray values, impractical values. As a result, we have this deviate here, the uniform deviate here. There's a deviate. This deviate has a constraint. It puts a constraint on my randomness, okay. So this has to range from 0 to 1, and when this is varying, my y also varying. So y cannot have any impractical values, because your deviate does not have any impractical values. As a result, you get a large data of y, and depending on that you can do the statistical analysis of it.